we're going to be discussing functions, particularly today we're going to be talking about the domain and range of functions. So a function is essentially a rule that will take some value and map it to another value. Now the domain, what we call the domain, is all the possible values that we can put into a function, and then the range is going to be all the values that we can possibly get out of a function. So for example, here's a function, it's called f of x, and it's going to have the rule 3x plus 2. Okay, so that means whatever value I put into this function gets multiplied by 3, and then we add 2 to it. And now what I'm going to do is I'm going to tell you what the domain of this function is. I'm going to tell you all the values that can be put into it. Now I can actually put in any value I want into this function. I can put in any value of x I want as long as it's a real number. But I'm going to restrict the domain, and I'm going to say that x can only be values greater than 2. Okay? X can only be values greater than 2. And this is what we call the domain. This is what we call the domain of a function. And essentially, the domain is all the values that can be put into a function. And another way of thinking about that is it's the input. It's what we can put in. So the input's a good word. But domain is all the values of x that we can put in. And I've restricted the domain on this question. I've told you that x can only be values greater than 2. So what we're going to do now is we're going to have a look at what this function looks like using Desmos, which is a free bit of software you can access on the internet. And we're going to have a look at what the function looks like and see if we can work out the range of values that we can get out. So here we'll go to Desmos site, desmos.com, and you launch the calculator. And the function we want is going to be 3x plus 2. And if I plot that on there, you can see the red line just comes straight up and cuts at 2 and so on like this. Now it's drawn this function for every possible value of x. So if I scroll up here, you can see for every value of x there's a value of f of x. But I actually said I only want values of x that are greater than 2. So if I use these curly brackets, I can say I only want x to be greater than or equal to 2. Okay. So let's see what we get now. If I have a look over here, you can see that now it's only drawn the graph for values of x greater than 2. So here's the x values across this axis, and it's only plotted the graph for values of x greater than 2. So another way of thinking about the domain is it's all the values along this x-axis, and I'm only considering ones greater than 2. So let's think about what we can actually get out. If I look up here, what I get out is this axis here, and it looks like I'm only going to get values out which are greater than 8, values 8 and above. So let's go back over here, and we're going to talk about what the range is. Now the range is what we get out. So what we get out are the f of x values. X is what goes in, but f of x is what comes out. And if I put 2 in to this, x is the lowest value I can put in. I put in 2, I times it by 3, I get 8. And if I put in anything bigger than 2, I'm going to get things out which are greater than 8. So the values that f of x can take, any values that are greater than or equal to 8. Okay? And this is called the range. Okay, this is called the range, and this is all the values that can be that the function can take. Or the output. Okay, so the domain was any values greater than 2 or equal to 2, and the range was any values greater than or equal to 8. Okay, so let's come down here and do another example, and this time let's have g of x is equal to a half x, and then we're going to take away 1. And I'm going to restrict the domain again. I'm going to say x can only be values that are less than 0, or let's say greater than -6. Okay, so I'm putting in a narrow margin of x values, all the values between 0 and -6, not including -6 and 0. So let's go back to Desmos and see if we can draw it. It's going to be a straight line, and it's x over 2, and then I'm going to take away 1, and let's just remove that one by clicking on it here. Come down and you can see I've got another straight line here, and again this is including all the x values, but now let's just talk about the domain that I specified, and that was from -6 to 0. Let's have a look, and you can see now it's only drawn the function from -6, values of x from -6 to 0, and look at the values I get out. So these are the values I'm putting in on this axis, and these are the values I'm getting out. Okay, so the range is going to go from this value down to this value. So let's see if we can work it out. If I come back over here, if I put in -6 into here, I'm going to get -6 divided by 2 is 3, and then I take away 1, which is -4. So that's the lowest value I can get. And if I put 0 in, I get 0 divided by 2, which is still 0, and then I take away 1, which is -1. So the range of this one, let's use a different colour, is g of x can actually be any value between -1 and -4. Okay, so this over here is the domain, and then this over here is the range. Domain is what goes in, and range is what comes out. Okay, let's just have a look back on the graph, see if we can see that between -1 and -4. Okay, good, that looks fine. So let's do another one. So let's have h of x, and h of x is going to be x squared plus 2. Okay, and I'm going to say let's have all the values of x which are less than or equal to 2, but greater than or equal to -3. Now on the last two questions we had straight lines, and we found that if I just picked the lowest value that x could take and subbed it into the function, it would give me the lowest value that the function could take. And if I subbed in the highest value that x could take into the function, I would get the highest value that the function could take. But this isn't going to work quite the same, okay, because this isn't a straight line. Let's have a look at what this graph looks like, x squared plus 2. So we'll go back to Desmos, and we're going to put in x squared plus 2. Let's get rid of that one. So we'll go back to Desmos, and we're going to put in x squared plus 2. Let's get rid of that one. And let's have a look at that. And you can see it's a quadratic. And this is for all the values of x across here. So let's just put in the values that I was talking about. I wanted to go from -3 up to 2. Okay, let's just check that's what I said. Yes, from -3 up to and including 2. Okay, So that's what I've put in there. And I get this bit of the graph here. This is what I've got sketched. Now this point up here is when I'm going to sub in -3. So when I sub in -3, I get -3 squared, which is 9 plus 2. So that value there is 11. And then the maximum value of x that I can put in is 2. And I'm going to do 2 squared is 4 plus 2 is 6. And this point over here is going to be 2, 6 then. Now if I'd used the same process that I used on the previous functions, you could, if you hadn't drawn the sketch, say, okay, well the range goes from 11 to 6. But that's not quite true, because I'm looking between these values -3 and 2, and you see that the function, the values it can take, goes from 11 all the way down to 2 and then back up to 6. So actually the range isn't 11 to 6, it's actually 11 to 2, because the lowest that the function takes between these x values is 2. So let's put that up there. So the range for this function here is that h of x can have any value which is less than or equal to 11 but greater than or equal to 2. And again, this is the domain, and this is the range. So it's always important to have a good idea of what the graph looks like between the values in the domain that you're talking about, and to even sketch it. You want to get good at sketching these things. So finally, we're going to talk about greatest possible domain. So on the functions that I've given you so far, the 3 functions I've given you, I've told you the domain. I've restricted the domain and told you certain x values that you're allowed to put in, and you worked out, or we worked out together, the range that could come out of that. So now I'm asking the question, if I give you the function, what's the most I can put into this function? What's the greatest possible domain? And what I'm really asking is, are there any values of x which I'm not allowed to put into this function? So let's start with the first one that we did. The first one that we did was a function of x equals 3x plus 2. And before I said that the domain would be values of x which were greater than 2. But actually, there's no reason for that, other than that I just asked the question. I can put in any value of x that I want. So the domain for this function, or the greatest possible domain for this function, is x can be any real number. And I can write that like that. X is a member of the real numbers. And that's a bold capital R, which means real numbers. And what values can I get out of it? Well, if I go back to the graph and we have a look on Desmos, and it was this one, 3x plus 2, and what I'm going to do is get rid of that domain so that I can just put any value in, and I zoom out, you can see, let's get rid of that one as well, you can see that for every value of x, there's a value of y. And if I keep going this way, to higher values of x, I get higher values of y. And if I keep going this way to negative values of x, the function's going to take negative values. So I can put any value of x in I want, so x can be any real number. And also the range is that f of x can be any real number as well. So what about the other function I was talking about? The last one. H of x equals x squared plus 2. What about this one? Are there any values of x which I'm not allowed to put in? Well, I can put in positive numbers and they get squared. That's fine. And I can also put in negative values for x and they're going to get squared. So again, there's no problems here. I can put in any value of x that I want. Okay? But let's have a look at the graph. Am I restricted by what values I can get out in the range? Let's have a look. Here's the graph. So I can put in any value in the x direction I want, can go into this, but look, only values in this direction that come out are values which are greater than 2. The graph is only positive here. In fact, it never goes below 2. It equals 2, but it doesn't go below 2. So the range for this function, when I can put any value in, I can only get values out which are greater than or equal to 2. Let's do 2 more. Let's have another function j. And this one can be 1 over x take 2. So I ask the question again, have I got a choice about what x values can go into here? Can I just put in any value of x that I want? The answer is no. I can't put in a value of x for 2. X can never equal 2. Because if x equaled 2, then this function would be 1 divided by 2 minus 2, which is 1 divided by 0, which I'm not allowed to do. So the domain for this one, or the maximum possible domain of this one, is x can be any value I want, but it can never be 2. So I can write that like that. X can never be 2. Let's have a look at the graph of this one. So it's 1 divided by x minus 2. And you can see, you should be able to see when we draw it, that x can have any value in this direction, except when we get over here to where x is 2, the graph doesn't exist there, it's undefined. So I'm not allowed to put an x into that graph. I'm not allowed to put an x into that function. And what values can I get out? Well, I can get any value out along here, but it doesn't seem to ever take a value at 0. Let's have a look why that is. Well, there's not one value of x that I can put in here that makes this fraction here 0. To make this fraction here 0, the numerator would need to be 0. So this function can never, ever equal 0. So its range is any value except 0. And we'll just do one more, I think. Let's see if we can do this one without the graph. fhj, let's have k, x, and let's say this is the square root of x plus 1. And I ask, are there any values of x which I'm not allowed to put into this function? Well, I'm not allowed to square root a negative. So x is not allowed to be anything less than -1. Okay, so the domain for this is x has got to be greater than or equal to -1. It can be -1, because -1 plus 1 is 0, and I can square root that. And it can be anything above -1, because that means I'm square rooting a positive. But if x were below -1, then I would be square rooting a negative, which I'm not allowed to do. Okay, so that's the greatest possible domain for that one. I've got to square root a positive number, so that means I can only put certain values of x in which make it so that I'm square rooting a positive. And let's have a look at the range. Well, what can I get out of this function? Well, if I square root a number, I get a positive and a negative, so the actual range for this function, I can get out any real number. Okay, and so that's domain and range. Domain is what is input into the function, and the range is what is output from the function.